Okie dokie. Let me go on to my Zoom folder so I have that ready. Awesome. We're going to continue in module 1, going through the AZ900 information. Today we're doing part 3 and 4. Just like I said last week, if you feel I'm going too slow, go on ahead. There is nothing saying you have to follow me at the speed that I'm going. You are more than welcomed to go ahead if you feel I'm going too slow. I know that a lot of this content that we're doing, especially in this module, is very fundamental. So if you feel like you have an understanding of this and you want to just complete it all, submit it in a week, and then jump to the skill submission, go for it. There's no negative to it. I mean, if you finish this class before the 16 weeks are done, that's a benefit to you. It doesn't harm me. You did all the work ahead of time. Perfectly fine. So, in part 3, I chose not to go through everything that is in the content. I will specifically cover each section's identify the product options and analyze the decision criteria. The other sections that exist in each of these little modules, I will leave to you to read through because it ties with the scenario that the content is building up over the Tradewinds company. So I didn't really think that was that fit with the talk and questions that we would have here. So with that, let's jump right in with choosing the best AI service for your needs. So artificial intelligence is a broad classification of computing that allows a software system to perceive its environment and take action that maximizes its chance of successfully achieving the goals. You have your 2 basic approaches to AI. The first is to employ a deep learning system. It's modeled on the neural network of the human mind. The second one is machine learning, a data science technique that uses existing data to train a model, test it, and then apply the model to new data to forecast future behaviors, outcomes, and trends. Your product options in Azure, the first one being machine learning. It's a platform for making predictions. It consists of tools and services that allow you to connect to data and train and test models to find one that will most accurately predict the future result. After you run experiments to test the model, you can deploy and use it in real time through like web APIs. The things you can do with this are things like creating a process to define how to obtain data, how to handle missing or bad data, split data into training sets, do predictive models, and use programming languages, creating pipelines to define where and when to run compute-intensive experiments, and deploy best performing algorithm as API endpoints to be consumed in real time. Another in the AI realm is the cognitive services. This one allows applications to see, hear, speak, understand, and even begin to reason. They'll solve general problems like analyzing text for emotional sentiment or analyze images to recognize objects or faces. For whatever reason, in my mind, I'm starting to think Skynet and the Terminator, but that's obviously not where they're going with this. It's more like the Sophia bot. You don't need special machine learning or data science knowledge to use these services. You can use it via API with a few lines of code. The categories that exist with it are the language services, the speech services, the vision, and decision. They also have bot service. The bot service or framework are platforms to create virtual agents that understand and reply to questions like a human. They're different from the prior two in that it has a specific use case. They can intelligently communicate with humans, and these bots can use other services to understand what they're being asked. Bots are basically used for simple, repetitive tasks. They can converse with a bot by using text, interactive cards, and speech. They can have quick answers to quick questions. But they're not meant to be smarter like the prior two. So you don't want to just walk in guns a-blazing and use everything that's provided in the cloud. You want to be specific in what you're using, namely because it has a financial cost. So that's where this second part comes in, the analyzing the decision criteria. For example, are you building a virtual agent that interfaces with humans using natural languages? Use the Azure bot when you need to create a virtual agent to interact with humans by using natural language. The bot service can integrate with sources, natural language processing, form factors that allow interactions across different channels. The bot service, like said before, it relies on other AI services. Before you build a custom one, see if there is a pre-built solution that'll help scenarios. And that might mean using certain subscriptions with pre-built products that are already in Azure. You could even use the Power Virtual Agents to build hundreds of connectors for data input. Here's another question. Do you need a service that can understand the content and meaning of images, video, or audio, or that can translate text into different language? For something like this, bot is not the way to go. For something like this, you want to go down the cognitive services. Do you need to predict user behavior or provide users with personalized recommendations in your app? Once again, this is not necessarily something for a bot to do. Maybe machine learning, but more likely you're going to go cognitive. Yes, I am talking. Let's see. Will your app predict future outcomes based on private historical data? So if we're talking about historical data that we already have to work with, that's going to be the machine learning. Do you need to build a model by using your own data or perform different tasks than those listed above? Then at that point, again, it's going to be machine learning. So again, you don't want to just jump in to one of the products that they have just because it sounds cool. Cognitive sounds cool, but maybe a bot could do the job better and cost less. Or maybe machine learning would be the more financially efficient way of using AI. Similarly, we'll move on to the next item, choosing the best tools to help organizations build better solutions. So here's a question before I move forward. It's a good one too. For our test environment, would you want us to implement AI from Azure for the skills showcase? The question is, or the answer is, it's up to you. I want to give you the freedom and flexibility to build infrastructure with this cloud provider. If you feel comfortable doing a showcase on implementation of AI, go for it. If you feel like that's just not something you want to deal with, that's perfectly fine too. There's quite a number of things that we're going to cover, so you don't have to restrict yourself to just one thing. Again, the skill showcase is demonstrating you understand how to use this by creating something of your own making on the platform. I'm not going to restrict that. And no, it doesn't have to involve something from all the feature sets. No, because that could mean a very huge project that you won't be able to complete in time. I do want you to use the various items and get familiar with them, but I'm not going to force you to use them all in your showcase. So this section is really eyeing DevOps, development operations, and the various products that live around DevOps. Starting with, the DevOps services. It's a suite of services that address every stage of the software development lifecycle, such as repos, boards, pipelines, artifacts, and test plans. They have a mature tool with a large feature set that began as on-premise and now has a SaaS use, a software as a service use. Again, these are 3 primary offerings that help with DevOps. The second one, which I kind of forgot, it's been a while. GitHub. GitHub is with Microsoft. That's right. They have GitHub. You can use GitHub within Azure. The other one that they have is the Dev Test Labs. They provide an automated means of managing the process of building, setting up, and tearing down virtual machines that contain builds of your software projects. This way, developers and testers can perform tests across a variety of environments and builds. It's not limited to VMs. You could do things in an ARM template. You could provision pre-created lab environments to test various software on their platform. Again, it's all about the cost. So here are some questions to ask to help determine which is the best route to go. Do you need to automate and manage test lab creation? If so, Dev Test Labs is probably the way to go. You can also automate provisioning of new labs as part of a tool chain with Azure pipelines or GitHub Actions. Are you building something that's open source? Well, the answer to that should be GitHub if you are building something that's open source. Regarding source code management and DevOps tools, what level of granularity do you need for permissions? Well, GitHub works on a simple model of read-write permissions to every feature. Azure DevOps has a much more granular set of permissions. So the answer to this question is, it depends. Do you want to just do read-write? Then GitHub is probably the way to go. If you want granularity, Azure DevOps. How sophisticated does your project management and reporting need to be? The answer is pretty similar to the one above. Although GitHub has work items, issues, and a Kanban board, project management and reporting is the area where Azure DevOps excels. It's highly customizable. allows admins to add custom fields to capture metadata and other information alongside each work item. So this question could be reworded again to say what level of granularity do you want your project management and reporting to be? And the answer would be the same. GitHub for not so granular, DevOps for granular. How tightly do you need to integrate with third-party tools? Now, they have an interesting little answer. Although we make no specific recommendations about third-party tools, it's important for you to understand your organization's existing investments in tools and services to evaluate how these dependencies might affect your choice. So in other words, it's up to you. They can't necessarily make recommendations for every possible choice, which that's fair. So they leave it up to you to decide how tightly you need it to integrate with third-party tools. The next section is choosing the best monitoring service for visibility, insight, and outage mitigation. All companies that use the cloud, and pretty much regardless of what cloud we're talking about, will ask the following questions. Are we using the cloud correctly? Can we squeeze more performance out of our cloud spend? Again, talking about money. Are we spending more than we need to? Again, finances. Do we have our systems properly secured? How resilient are our resources? If we experience a regional outage, could we fail over to another region? How can we diagnose and fix issues that occur intermittently? How can we quickly determine the cause of an outage? And how can we learn about planned downtime? So the products that they have at a high level, number one is the Azure Advisor. It evaluates your resources and makes recommendations to help improve reliability, security, and performance, achieve operational excellence, and reduce costs. Advisor is designed to help you save time on cloud optimization. You can take the suggested actions right away, postpone or dismiss for a later time. They're available in the Azure portal and the API, and you can set up notifications to alert you when it has new recommendations. You'll see things like the reliability, security, performance, cost, and operational excellence. These are the 5 categories of recommendations that you'll see there. The picture here on the right is Azure Monitor. It's the platform for collecting, analyzing, visualizing, and potentially taking action based on the metric and logging data of your entire Azure and on-premise environment. On the left of the picture, you have the list of sources for logging and metric data that can be collected at every layer in the architecture. In the center, you can see how the logging and metric data is stored in central repositories. And on the right, the data is used in a number of ways, from real-time and historic performance or aggregated. You can see it displayed different ways for different audiences. You can create custom views as well. You can react to this data in real time, especially for those critical events. You can send those alerts via text, email, and so on, and use thresholds to auto-scale any functionalities that are necessary. You also have the Azure Service Health. Provides a personalized view of health of the Azure services, regions, and resources you rely on. The site is status.azure.com, which displays only major issues that broadly affect Azure customers. It doesn't show the full picture. The Azure Service Health will display both major and smaller, more localized issues that can affect you. These service issues can be rare, but it doesn't mean that they're impossible and they'll never happen. Now, we've had outages like with Cloudflare that affect so many people in one shot. So never think that just because it's on the cloud means that you are 100% safe and it'll never go out. So using those three, we have a couple of questions to help again decide which one do we need. Do you need to analyze how you're using Azure to reduce cost, improve resilience, or harden your security? For this, it would be the first, the Azure Advisor. How about monitoring the services or your usage? That would be the service health. However, if you want to keep track of performance or issues related to specific VMs or containers, Monitor would be your way to go. Do you want to measure custom events alongside other usage metrics? For this, it would be Azure Monitor, because it can collect things like telemetry data and make custom events. Same with this one, setting up alerts for outages or when autoscaling is about to deploy. Monitor would be your way to go. Any questions, feel free to put them in the chat. And that chat could be Zoom, YouTube, or Discord. We have 3 more of these, and then we'll move on to part 4. This part is choose the best tools for managing and configuring your Azure environment. The 2 broad categories of managing tools are the visual tools and the code-based tools. Your code-based tool is things like infrastructure as code. Your visual tools will give you friendly access to functionalities. Your options are things like the Azure portal, the web-based user interface that you see when you log in, the nice friendly graphical UI, as they say. You have the mobile app for iOS and Android to manage your resources when you're not on your computer, but you want to stay connected. You also have the Azure PowerShell with commandlets that allow you to connect to Azure. Azure PowerShell runs on Windows, Linux, and Mac, and even in a web browser. You have the Azure CLI, an executable program which a developer, DevOps, or IT can execute commands in Bash. They call the REST API to perform every possible management task in Azure. In a lot of ways, the Azure CLI is identical to PowerShell in what you can do. The difference between the two is the syntax that you use. If you are already proficient in PowerShell or Bash, you could pretty much just pick and choose which one you want to use. My personal choice would be the CLI because I'm more familiar with Bash than PowerShell. But again, you could do basically the same thing with either. They also have ARM templates. These Azure Resource Manager templates, you can describe the resources you want to use in a declarative JSON format. The benefit is that the entire Azure Resource Manager template is verified before any code is executed to ensure that the resources will be created and connected correctly. The template then orchestrates the creation of those resources in parallel. That is, if you need 50 instances of the same resource, all 50 will be created at the same time. So once again, we ask the same question. We have these tools. Which ones do we need to best answer questions like, do you need to perform one-off management, administrative, or reporting actions? Well, for this, it could be PowerShell or CLI. It could also be, it could be ARM, since it expresses requirements for your application for a repeatable environment. It's not necessarily good for a one-off, but you could use it to build those templates that you could use later. Your very last option could be to use the mobile app to do one-offs. Do you need a way to repeatedly set up one or more resources and ensure that all dependencies are created in the proper order? That is definitely the answer. Or the answer to that is definitely the ARM templates, because it'll do exactly that. You could do PowerShell or CLI, but why do that when you already have a template that can verify everything for you? When you're scripting, do you come from a Windows admin or Linux admin background? Again, like I said earlier, if you are familiar and well-versed in PowerShell, then use PowerShell. If you're like me, who is very much used to Bash, then Azure CLI would be the way to go. Your next set of products. Choose the best Azure serverless technology for your business scenario. Oops. Hey, it's okay. Serverless computing is a cloud-hosted execution environment that runs your code but abstracts the underlying hosting environment. Yes, there is a server, but you're not responsible for setting up or maintaining it. You don't have to worry about scaling. You don't have to worry about outages. That is all on the cloud vendor side. All that you're doing is you create an instance of a service and you add your code. The two that Azure has are functions and logic apps. Functions, you can host a single method or function by using a popular programming language in the cloud that runs in response to an event. An example of an event might be an HTTP request, a new messaging queue, or a message on a timer. Because of its atomic nature, functions can serve many purposes in application design. You can write these functions in things like C#, Python, JavaScript, TypeScript, Java, and PowerShell. These scale automatically, and charges only go when a function is triggered. These qualities make Azure Functions a solid choice when demand is variable. For example, you might be receiving messages from IoT device that monitors a fleet of delivery vehicles. You'll have more data arriving during business hours, and you could scale during those busier times. Azure Function is a stateless environment. It behaves as if it's restarted every time it responds to an event. This feature is ideal for processing incoming data. If a state is required, you can connect it to a storage account. Azure Function can do orchestration tasks with an extension called durable functions to chain functions together while maintaining state. Lastly, your Azure Function solution is ideal when you're concerned only with code that is running your service and not the underlying platform or infrastructure. On the other hand, logic apps. They are a low-code or no-code development platform hosted as a cloud service. The service helps you automate and orchestrate tasks, business processes, and workflows when you need to integrate apps or data systems or service across enterprise or organizations. Yes, the resources can scale dynamically with functions like increasing RAM without downtime. Yeah, that's the whole point. The primary difference between these two services is their intent. Functions is a serverless compute service, and logic apps are intended to be a serverless orchestration service. And they're also priced differently. Function pricing is based on the number of executions. Logic apps is based on the number of executions and the type of connectors that it utilizes. But for both, yes, the whole point is you don't care about what's happening under. It's not a concern. What sort of app? Things like web apps is one thing that could use them. So, for example, do you need to perform an orchestration across well-known APIs? For this is logic apps because it does orchestration and can connect a large array of disparate services through their APIs to process data. Do you need to execute custom algorithms or perform specialized data parsing and data lookups? That could be functions. And although logic apps can perform logic-based decisions like loops, if you have logic-intensive orchestration, then you might want to switch over to logic apps. But things like maintaining code, handling exceptions, data lookup, that could be done with functions. Do you have existing automated tasks written in an imperative programming language so that it would be easier to port your code into an Azure function than recreate it in a logic app? Do you prefer visual or writing code? That one, the choice comes to whether you prefer one or the other. So that could be either or. That could be a function or that could be the logic app. The last one in this set is IoT. So what product options do they have for IoT? to handle sensors that do things like environmental, capture the temperature, humidity, barcode, QR, geolocation, color sensors, infrared, sound, motion, all that kind of stuff. Well, you have the IoT Hub. It's a managed service hosted in the cloud, of course, that acts as your central message hub for bidirectional communication between your IoT application and the device that it manages. Basically, IoT Hub is your command and control for your IoT devices. There is also IoT Central. This actually works on top of the IoT Hub by giving you a dashboard to connect, monitor, and manage those IoT devices. So it gives your command and control a nice GUI to use. Yes, it does sound a lot like a dashboard for syslog aggregation. There is also Azure Sphere. Creates an end-to-end, highly secureable IoT solution for customers encompassing everything from hardware and operating system on the device to secure method of sending messages from device to the message hub. Here is a picture of the IoT Central, your nice, pretty UI that will go on top of Hub, your command and control. Here is a picture of the microcontroller unit responsible for processing the operating system and signals from attached sensors. This one displays the Seed Azure Sphere MT3620 development kit, one of several starter kits that are available for prototyping and developing Azure Sphere applications. The second part is a customized Linux OS that handles communication. And the third part is the Azure Sphere Security Service, or known as AS3. That's what handles, its job is to make sure that devices are not maliciously compromised. Kind of cool, because your IoT devices are normally insecure by default. So having a function that, hey, not only can I control my IoT devices, but I have a device that I can add to ensure security, sounds interesting. Here are two financial questions. Is it critical to ensure that the device is not compromised? Azure Sphere would be the way to go. And do you need a dashboard for reporting and management? That's where you need not the hub, but IoT Central to create those reports. You know, I actually don't know if the chip is universal. My guess is that they would want to make it universal, or at least as much as possible. They do mention that there are a number of kits. So maybe if it's not universal to one, it's it could do another. That could be fun to see if you can connect your fish tank to it and not get a breach. Or at least be able to detect a breach on your IoT devices. How would you attach various IoT devices? Well, I'm sure that they have some form of agent that you would have to install on your IoT device, or use a product like that IoT Sphere to connect to it and then connect up to Azure in order to secure your devices. That could definitely be a fun presentation if the kits are not expensive and they're really useful and whatnot. Yeah, that's my guess too, is that they would connect physically to it. That could be an interesting experiment. Part 4 is not too long. It's actually made up of 2 modules. So this first one is security threats. Azure has the Security Center, a monitoring service that provides visibility for your security posture across all of your services, both on Azure and on premises. It can monitor security settings. It can automatically apply security settings to new resources, provide recommendations, continuously monitor resources, use machine learning to detect and block malware, detect and analyze potential inbound attacks, and provide just-in-time access control for network ports. Something that you could see in the security center is something like this, where, for example, let's say our infrastructure that we're using for our skill submission, we want to make it PCI DSS compliant. We can use this to tell us how close is our infrastructure to be compliant to that law, and be able to dig further to see what we're missing, what's not working, and what's not covered, et cetera, et cetera. There's a resource security hygiene section that shows you the health of your resources from a security perspective. This way, you can choose, you can prioritize, better said, your remediation actions. For example, I see a lot of red in the compute and apps, but I don't see so much in data security. If I have to prioritize what I need to work first through, I'm going to go with the highest severity first, then the mediums and the low. This secure score is a measurement of the organization security posture. So it's your overall. It's based on the security controls or the groups of related security recommendations, based on the percentage of security controls that you satisfy. The more you satisfy, of course, the higher the score it'll be. To protect against threats, you could use capabilities like the just-in-time VM access to block specific network ports or virtual machines, adaptive application controls, where it works in the background using machine learning, adaptive network hardening to look at the network security groups and see if there's something fishy coming in, and file integrity monitoring, just like you do in Windows or Linux, or if a essential file is getting edited, it would call it out. What would it consider a high severity alert for compute and apps? Well, it could be outdated services, for example, running in a VM, or VMs that are not up to date, or settings that are not up to compliance. So let's say like passwords aren't set to be 8 characters or longer, or password history hasn't been set properly. Those could trigger high severity, along with missing patches. Yes, it's supposed to do all those things. It's supposed to scan for open ports that shouldn't be open. And yes, you can tune it to be dependent on your compliance standard. There are a couple of ways to detect and respond to security threats using Sentinel. It can collect cloud data at scale across all users, devices, applications, and infrastructure on-premise or multiple clouds. It can detect previously undetected threats using analytics and threat intelligence. It can investigate threats with AI and respond to incidents rapidly. You can connect your data sources to Sentinel for it to add to the realm of things that it will analyze. Anything from like 365 sources, Azure Active Directory, Defender Firewall. It can do non-Microsoft stuff like AWS, Citrix, Sophos, VMware. It can connect with industry standard data sources like Common Event Format, syslog, REST API. Sentinel has built-in analytics built by Microsoft's teams to detect any things that are fishy happening on the network. You can also make custom analytics as well. The picture that I have here is a picture of Azure Sentinel, showing you various connected items together and where possible threats exist. And you can take actions when an alarm is triggered by opening a ticket, sending messages, you could use even email to do things like block or ignore if need be. It seems that it does integrate with Windows Defender on either remote or virtual systems, since it does work with on-premise and on the cloud systems. Key Vault is a centralized cloud service for storing an application's secrets in a single central location. It has, it can hold sensitive information with access control and logging capabilities. It can manage secrets like tokens, passwords, certificates, API keys. It can manage encryption keys for you. It can manage SSL and TLS certificates and hardware security modules, any store secrets backed by them. Here's just an example that shows a certificate used for testing in Key Vault. Your benefits are centralized application secrets, securely storing secrets and keys, access monitoring and access control, simplified administration, and integration with other Azure services. Now, I will point out that just because they have this function doesn't automatically mean everything is secure and safe. You still have to apply your own security, like making sure that your account, it has multi-factor authentication and whatnot. Because the last thing you want is to use something like Key Vault and feel that everything is safe, but because your account has a weak credential, it gets breached, and now all this stuff is out and about. On Azure, VMs run on shared hardware that Microsoft manages. Though the underlying hardware is shared, your VMs are all isolated, according to Microsoft. Some organizations have to follow regulatory compliance that requires them to be the only customer using the physical machine that hosts the VMs. For that, Azure has the dedicated host to do that, where you have all your VMs running on a dedicated host in a physical server. You could use a host group, which is a collection of those dedicated hosts, or a single dedicated host. Again, it'll give you that visibility and control over those devices that are under your control now. For high availability, you'll definitely want to use a host group. You are charged per dedicated host, independent of how many VMs you deploy to it. The host price is based on the VM family, the type, like the hardware size and the region. Software licensing, storage, and network usage are billed separately from the host and the VMs. So keep that in mind if you have to have dedicated systems, because that is how you will meet compliance. Know that the pricing is per dedicated host, independent of the VMs you have, not counting software licensing. Our final section is defense in depth. And if you have taken my CIS 75, this is pretty much going to be review. Defense in depth, a series of layers with the data to be secured at the center. Each layer provides protection so that if one is breached, the subsequent is already in place to prevent further exposure. It slows down an attack and provides alert telemetry that security teams can act upon, either automatically or manually. So we have the physical security layer, the first line of defense. You have identity and access. Layer controls access to infrastructure and data and change control. Perimeter layer uses distributed denial of service protection to filter large-scale attacks before they cause any issues. The network layer limits communications between resources through segmentation and access controls. Compute layer secures access to virtual machines. Application layer ensures that applications are secure and free of security vulnerabilities. And then data is the data you want to protect. They have a number of ways that they secure all of this. They have physical security across all their data centers. At this layer, things like single sign-on come into play, multi-factor authentication as well. Always auditing events and changes. That can be done on either the cloud provider or your end. Perimeter. They have the DDoS protection that you could use. Use perimeter firewalls as well. At the network layer, it's important to limit communication between resources, deny by default, restrict inbound internet access and limit outbound access when appropriate, and implement security connectivity to on-premise networks, since again, the idea of this is you're connecting your on-premise to the cloud. At the compute level, of course, we want to secure our VMs and ensure endpoint protection. At the application layer, we want to ensure that apps are secured and free of vulnerabilities, that we store sensitive application secrets in a secure storage medium, and make security design requirement for application development. Lastly, in almost all cases, attackers are after data that is stored in databases, stored on disks inside virtual machines, stored in software as a service applications, and managed through cloud storage. As a recap of CIS 75, you should be implementing the CIA triad: confidentiality, using the principle of least privilege; integrity, preventing unauthorized changes to information; and availability, only available to those who are authorized to see and use that data. Some protections that already exist that you can take use of are things like the Azure Firewall. It's a managed cloud-based network service that provides security for your network. Here is just an example of it. The Azure firewall is a stateful firewall. So it'll analyze the complete context of a network connection, not just an individual packet. It has high availability and unrestricted cloud scalability. So you can do things like high availability, inbound and outbound filtering rules, inbound destination network address translation, and monitoring. You can configure application rules to define fully qualified domain names that can be accessed from a subnet. You can have network rules that define source address, protocol, destination, port, and address, and NAT rules as well. They do have a web application firewall that you can use for your web application specifically. Along the list of tools that they have is DDoS protection. DDoS protection standard will protect you against most DDoS attacks. The protection identifies an attacker's attempt to overwhelm the network and block further traffic from them, ensuring that it never reaches the Azure resources. Legitimate traffic will still flow in without interruption. It can also help you manage your cloud consumption. When you have on-premise, you have the fixed number of compute resources, but in the cloud, it's elastic. So a cleverly designed DDoS could cause you to increase your resource allocation. And it will let you know when your network load is getting out of whack. They do have the basic service tiers, basic and standard. Basic is automatically enabled as part of your free subscription. Standard provides additional mitigation capabilities. And again, and that depends on, do you want to pay or do you want to stay with what they provide freely available to you? With standard, you can dig a little further than you can with basic. The standard tier will help you with things like volumetric attacks. That's attacks to flood the network layer. The protocol attacks that'll try to target weaknesses in layer 3 or layer 4. And resource layer, like web application firewalls at level 7. I might have skipped something here. Yeah, I did. You could use, before I jump into this, let me just go back slides so that's not confusing. Oh, there it is. You can filter network traffic with security, network security groups. Here are the things you need to define those network security group rules: the name, the priority, source of destination, protocol, direction, port range, and action. You can't remove any default rules that exist, but you can definitely override them by creating ones with higher priorities. These are just another way of filtering your network traffic from your resources with a virtual network out to the world. These, you can consider the NSGs as an internal firewall. And then this slide, combining them to create a complete network security solution. So to secure your perimeter layer, you could use the Azure DDoS and use perimeter firewalls with Azure Firewall. At your network layer, we could restrict connectivity to reduce the risk of lateral movement throughout your network from an attack. So limit communications between resources by segmenting your network and configuring access controls, using deny by default, restrict inbound internet access and limit outbound when appropriate, and implement security connectivity to on-premise networks. You can combine services with like the network security groups. Since Azure Firewall is fully stateful, it can work with them. You could use the application gateway and the Azure Firewall together to protect your web applications, and along with inbound protections from like RDP, SSH, FTP, and so on. Are there any questions on all these topics that we have covered? Looking around, looking around. I don't see any new questions. So as always, go through the content. There are a number of exercises and knowledge tests at each of them. You'll complete them. That'll grow your XP. You take a screenshot of those and you stick those in the part 3 and 4 submission. And if you have any questions, namely, if you are not able to, if you're not able to get the Azure credit, let me know so that I can talk to Marcelo. Oh, I see a question. If we want to stay on pace with the classes, by next Monday, you should be done with 1 through 4, with parts 1 through 4. So last week we did 1 and 2. This week we did 3 and 4. Next week we'll do 5 and 6. And again, like I said at the beginning, if you feel this is too slow, go ahead and go faster. There's no penalty to that. If there are no other questions, I will end the stream and stop the recording.